We're going to be drawing a part with a section view, so let's go back and review what we know about section drawings. This will be a repeat from last year when you had mechanical drafting, so we just want to go over the standards and the basic ideas. First thing to keep in mind is the good old glass box. The idea is that when you cut a section through a part, you slice through it with an imaginary saw blade and you throw away the front part, but the top and front, or whatever views you're working with, are still the same old views inside a glass box. It's just that you threw away the front part. So for example, here we see this part, we still have the top and the front section view. Remember that cutting plane lines are thick, so they are thick like object lines, and they can be either phantom lines or dashed lines. I like phantom lines. I can't tell you why, but dashed lines are equally okay. Main thing is they need to be thick. Here's the ASME line type standard. And the arrows on cutting plane lines are twice as big as dimension arrows. So if you think about what size dimension arrows are, they are 1/8 of an inch long. That means arrows on cutting plane lines are 1/4 of an inch long. There's no standard for how far beyond the part the cutting plane line has to extend. 1/2 an inch is a nice distance, but it really is all up to you. The main thing is make sure you get the arrows pointing the right direction. You're showing the reader what direction their eyeball is looking when they are looking at the section view. You might remember this handy time saver that when you have parts with circles in them and center lines, you can omit the cutting plane lines because the center lines are the cutting plane lines. Now in the part that we're going to draw, we do need cutting plane lines, as you'll see in a minute, because we're doing on a line section. But if this were just a straightforward cut, you could just use the center lines to stand in for the cutting plane lines. And we never label the views. They're just like regular orthographic views inside a glass box. We only label them if they are not aligned. If you have to pull this section off to some other place on your sheet, then you label it. And we use thin lines for hatching. Usually they're 45 degree angle. However, if the part you're drawing were at a 45-degree angle, that wouldn't look so good because the hatch would look like it was some edge on the part. So you have to use your judgment. Sometimes you might need to rotate your hatch lines. And in mechanical drawings, we do not use this old-timey system where you use different hatch patterns to represent different types of materials. For several reasons. One, there are thousands of materials, and two, we have bills of material where we can list the materials anyway, so why bother with it? We just use this one, plain 45-degree lines. In AutoCAD, that's called the ANSI 131 pattern. Remember that we do not show hidden lines in a section view. This is the kind of thing we're going to do in our drawing, an aligned section, where, for example, in this part, we're wanting to show a section through a straight across arm and an arm that's rotated up at an angle. And so the standard is that you draw the section as if those two arms were 180 degrees apart. Here's another example from ASME. They draw the section as if those two arms were 180 degrees apart. And here's the thing we're going to draw. I grant you this is kind of an old-timey drawing. You can tell by some of the stuff on here. This was a part for a crane and hoist company that's, since they made this drawing, they've been bought and sold a couple of times. But we've still got their drawing in our textbook. And so what we have is in the, I guess call it the front view, even though it's over here, we have holes on two different diameter bolt circles, and they are at angles to each other. We have a section view that will show the reader how this hole is bored through the middle, what some of the steps and grooves look like, and what these grooves for the V-belts look like. This, on the left half of this part, this is a sheave for a V-belt drive, and so we are detailing the grooves. We're going to do an enlarged detail, so here's a call out around the grooves, and then here's an enlarged detail. And we're going to do an aligned section, which I've highlighted in yellow here, where we have a cutting plane line at an angle, and that shows the reader what we're showing over here. So a bunch of stuff going on here. Let's see, one other thing to point out is the threaded holes. There are 4 threaded holes. Note the hidden lines around the outside of those circles representing threads. The one odd thing here is that they are combining inch dimensions with metric threads. So that'll give you just a little practice calling out a metric call out. But all the dimensions are going to be in inches. They've done something that we don't do anymore. They've labeled the section arrow with A and A, and then over here in the section view they labeled it section AA. If I were you, I would not label it. I would just make the cutting plane arrow and the section view and call it good. So now I want to make another quick video and go over to AutoCAD and look at a little bit about hatching and arrows. And then next time we will look at how to put these tolerances in your drawing and how to make enlarged details in your drawing.